1 over 1 plus cosine of negative x plus 1 over 1 minus cosine x. So we know cosine is even function, then cosine of negative x is equal to cosine x, right? So we just got the 1 over 1 plus cosine x and plus 1 over 1 minus cosine x. And these two fractions have the different denominator. We need to reduce them to the common denominator, right? So the least common denominator is just the product of these two denominators. So we may rewrite this first one as the equivalent fraction with the LCD as the denominator. So this is the 1 minus the cosine x over 1 plus cosine x and times the 1 minus the cosine x, right? Actually, we multiply both the numerator and denominator by the 1 minus cosine x. And for the second, we multiply both the numerator and denominator by 1 plus cosine x. Now, these two fractions have the same denominator, then we may just add the numerators. So you add these two numerators. So 1 plus 1, 2. Negative cosine x, positive cosine x cancel. So you got a 2 for the numerator, right? And the denominator, you may use the formula of the product of the sum and the difference of two terms. You know, you have the a plus b times a minus b equal to a squared minus b squared, right? So now you get 1 minus cosine squared x, right? And the 1 minus the cosine square x is equal to what? Sine square, right? By the fundamental identity, you get the 2 over the sine square x. And then use the one of the reciprocal identities. You get a 2 times cosecant square x. Now let's look at some examples and determine whether the given function is odd, even, or neither. Let's look at the 50, okay, on the page 517. Let me write down this function on the whiteboard. Page 517. Problem 50, we have f of x equal to 2 times sine x times cosine x. To determine a function, if a function is odd, even, or neither, you may just first get the f of the negative x and then compare this to the f of x. Okay, let's first get this. 2 times sine of the negative x times cosine of the negative x. And sine is odd, right? So we got the negative 2 times sine x. And cosine is even, so cosine of the negative x is equal to cosine x. And then you compare this one with this original f of x to see if it is equal to f of x or negative f of x or neither. So right now, this is equal to negative f of x, right? So that means we have the f of the negative x equal to negative f of x for all x in the set of the real numbers. So that means this function f is an odd function, right? So f is odd. Let's look at another example. 54. F of beta is equal to 1 plus the cosecant beta. And let's get the f of negative beta. So it's equal to 1 plus cosecant of negative beta. Tell me, cosecant function is even or odd? Odd, right? Because cosecant is 1 over sine, and sine is odd, so is cosecant. So this guy is equal to 1 minus cosecant of beta. Okay. Now you compare this one with the f of beta. That is 1 plus the cosecant beta. So definitely f of beta is not equal to f of the negative beta. So that means this function is not an even function, right? And then you compare this f of the negative beta with the negative f of beta, which is equal to negative 1 minus cosecant of beta. And you can see this one is not equal to 1 minus the cosecant of beta, right? So that means f of the negative beta not equal to negative f of beta either. So this function is neither odd nor even. So f is neither. Okay, done.